Hi, this is Chapter 5, Temperature and Heat. Well, what is temperature and what is heat? Let's start with temperature. In the winter, one day is very cold outside. Let's say in the morning when you get up, when you go outside, you see a tree. You see a tree over here, okay? And there's a metal bar. So now you can use your left hand to touch the tree and use your right hand to touch the metal bar, okay? The question is, which hand that you will feel colder, okay? Many of you, by our common sense, will say, of course, the hand that is touching the metal will feel colder, okay? Or if there is a styrofoam cup outside overnight, when you touch them, you will feel that when you touch the styrofoam cup, you don't feel that cold. But when you touch the metal bar, you feel very cold, okay? However, if I ask you, which one will have a lower temperature then? Will the tree over here has a lower temperature, or the metal bar will have a lower temperature? Well, I'm sure a few of you will say, of course, the metal bar will have a lower temperature because I feel colder when I touch the metal bar. Guess what? That's not right, because they are just outside. Let's say outside is at night is 35 degrees Fahrenheit. That means when you go outside, if you measure the temperature, they will be both 35 degrees Fahrenheit if you measure the temperature, because it's outside, they both exposed to the same temperature. Okay, so what is temperature then? Temperature is the average measurement of the kinetic energy of the molecule. That is very abstract. Let's make it simple. How do we measure the temperature? Well, the easy answer will be by using a thermometer. So I'm going to show you how some of the thermometer work. Okay, the most common one that you see is you have a container. I'm running out of ink. You have a container that you reserve some of the liquid inside. Okay, so when you heat up the liquid, for example, if you use a candle to heat up the liquid, the level of the liquid is going to raise because of thermal expansion. And not very strictly, but by thermal expansion, when you heat it up, it will expand. The expansion coefficient is almost constant within certain range. That means if you heat it up more, then it will expand more. And it's proportional to the amount of heat and temperature that it exposed to. Okay, so this is one type of thermometer. It's based on thermal expansion. There's another type of thermometer also based on thermal expansion, but you need two different materials. Okay, so for example, on the left side, what you have is iron. On the right side, what you have is copper. Because they don't have the same thermal expansion coefficient. For example, copper, if it expands faster than iron, so what will happen with this piece of metal, bimetal, that stick together? When you heat them up, because the copper will expand faster than the iron, that means it's going to bend. If you heat it up, it's going to bend. If copper expands faster, it's going to bend to the left side. Okay, so you can make a thermometer based on this principle. If you fix this point and you see how much it will bend to, okay? Or if you look at some of the commercial available thermometer, then you see a coil of the bimetal plate, okay? They make it round and round many times, so a little bit difference in thermal expansion coefficient, then you're going to see a big effect. Okay. The other one is called a thermocouple. A thermocouple is based on you have two different metals this is a metal wire. This is one type of metal. This is the other type of metal. When you have a connection over here, then you're going to create a difference in voltage. It is very, very small, but it's enough, big enough that you can actually measure just by having a metal wire that made of two different materials. Then when you measure the voltage between these 2 points, okay, let's say it's 0.001 volt, okay, 1 millivolt, then we can calibrate this thermometer, because when you heat it up, then the voltage will be different, okay? All right, so let's look at the other ones. Well, there are many, okay? I'm just going to tell you some of them. The other one, this is called thermocouple. The other one is called the RTD, okay? That means you have a long metal coil, okay? So what you're going to do is you're going to measure the resistance of this metal coil. Usually when you heat them up, you're going to increase the resistance, okay? That's why when our computer is running, we don't want it to run too hot because you will have a higher resistance. That's why we always try to run our electronics at a lower temperature. In that case, you have a lower resistance. But based on this principle, that is, the resistance is inversely proportional to the temperature, then we can calibrate it and we can use that as a thermometer.